this video, we're going to talk about how to find the horizontal intercepts, and in this case, we're going to think about using the factoring process using a GCF and apply the zero product principle. But along the way, we might have to use a quadratic formula as well at some point in order to go all the way to find the horizontal intercept. And for the first function, we have 60t squared plus 70t plus 60. Whenever we're trying to do the factoring process, we want to go through the GCF process first. And for this one, if we look at the GCF between the three constant coefficients, we have the factor being 10. And we can check the variables as well. In this case, because the last term is a constant term, it doesn't have a variable term. So we don't have anything that all three terms share in common with regard to the variable. So we're pretty much done with the GCF. And once we factor out 10, we're left with 6t squared plus 7t plus 6 as the result. And now if I want to find the horizontal intercept, that means I want to set the function to be equal to 0. And once I do this, I have the option of either 10 equals 0 or whatever I have in the parentheses is equal to 0. First of all, we know 10 cannot be equal to 0. They're just not equal. And that tells me really 6t squared plus 7t plus 6 is equal to 0 in this case. And that's my only possibility to find the horizontal intercept if they exist. And to solve this one, right now the tool we have is a quadratic formula, so we can go ahead and use it over here. And just a reminder, t is equal to negative b plus minus square root of b squared minus 4ac all over 2a. It doesn't matter what the input is here, the input is t. And now if we plug everything in, negative b is negative 7 plus minus square root of 7 squared minus 4 times coefficient 8, which is 6. That was the first 6, right? That's A, B, and C. And times C, which is also 6, coincidentally. And this is all over 2A, so 2 times 6. And now if we want to simplify this, we want to work with the radical part first. So I'm not even going to worry too much about the other parts. And in the radical, we have square root of 49 minus 4 times 6 times 6. If you calculate it, 24 times 6 will be 144, I believe. And as we do so, it's all over 12. But what we want to notice is under the radical, we will have a negative number. And we know we can't take square root of a negative number and find a real number as a result. Because of this, we would say there's no solution based on our real number requirement. So therefore, we say there's no such real value for t over here. So we can say there's no real solution for t, real being real number. And therefore, there is no x-intercept at all. It doesn't produce any result. No horizontal intercept or t-intercept in this case. And that would be our conclusion. Then we can take a look at part B, which we can go through a similar process. It's a higher degree function, so we have a little bit more to work with over here. First thing, again, we want to look at the constant coefficients and see what they all share in common. And if you want, you could alternatively change everything to go from the highest degree to the lowest degree first, because we know if we want to use a quadratic formula, we are assuming the degree is going from highest to lowest in terms of assigning A, B, and C. If that order matters to you, definitely go ahead and rearrange things. So if we want to do so, we would get negative 1214x to the 4th first, plus 6x cubed, plus 3x squared. Make sure to carry the sign in front of the coefficient at the beginning of the term for each term. That's part of the coefficient. And now if we want to look at the constants, the greatest common factor we can take out would be -3. And I like to factor out the negative sign in the leading term just so I don't have to deal with it later. It makes all the calculations a bit easier later on. And if we factor out -3, we are left with, and that's a constant part, then we're left with a variable part to consider. Here among the three terms, they all share x as a variable, and the lowest degree of x I have is x squared. So that's also part of the GCF. And as we do this, we are left from the first term 4 times x squared, because I factored out 2 of the x's and I'm left with another 2. And then for the second term, because I factored out a -3, I'm left with a -2. And I took out 2 of the x's, I'm left with another x. And lastly, for positive 3x squared, if I took out the -3x squared, I'm just left with a -1. This is really important to put down over here because we need a term in the end. Even though it looks like you took everything out, you really didn't. need a placeholder, right? You can't take everything out through factoring. You are essentially thinking you are left with a factor of 1 or -1 at the end. That's a really important term to write. We won't miss a term through factoring. And now that we have this factored form, we can set this all to be equal to 0 to find the horizontal intercept. And that leaves me with either -3x squared equal to 0, in other words, x squared is equal to 0, or 4x squared minus 2x minus 1 equal to 0. Let's work with x squared equal to 0 first. You can take the square root on both sides, or you can also use a zero product principle again to get x times x is equal to 0. In other words, x is equal to 0. And then we can also have the result of the other part using the quadratic formula. So same thing as before. We have -b plus minus square root of b squared minus 4ac all over 2a. And as a result, we would get -b, which is positive 2, plus minus square root of -2 squared minus 4 times 4 times -1. Make sure you carry all the signs for the constants. And 2 times 8 would be 2 times 4. And therefore, if we calculate it, we get x is equal to 2 plus minus. Under the radical, we have -2 squared, which is 4, and then we had plus 16, because the negative signs are combined, all over 8. And once we do this, we will see that we have square root of 20 down below, or sorry, on the top. And then we get x is equal to 2 plus minus square root of 20 all over 8. This is where we can simplify square root of 20 a little bit to see that this is really equal to square root of 4 times square root of 5. And essentially what I did is I'm looking for the perfect square number that's a factor of 20 over here, and I want to take that out by itself. And with this, I know square root of 4 is equal to 2, so this is equal to 2 root 5 over here. And we get the result, x is equal to 2 plus minus 2 root 5 all over 8. And if you notice, all the terms we have here have a factor of 2. So we can factor out 2 on the top and bottom. So the 2's are cancelled out, and I'm left with a 4 over here as a result. So when you're canceling out the terms or canceling out factors over here, you want to make sure every single term we have is divided by 2. So make sure you do this, and we will have the intercepts being the point 0, 0 that we found earlier, and the point 1 plus root 5 over 4, comma 0, and then we have 1 minus root 5 over 4, comma 0. Again, when you're canceling out things, I cross out the 2's, but really these are 1's over here. and these are going to be the horizontal intercepts we have. And here we got 3 horizontal intercepts for a 4th degree function.